Good day everyone. Today I will be discussing the graphing trigonometric functions. We will explore their periodicity and amplitude, analyze their general behavior, and determine their domain, range, and characteristics. To begin, let us recall the six trigonometric functions: sine, cosine, tangent, cosecant, secant, and lastly cotangent. Each of these functions has unique graphical characteristics that are based on their amplitude and periodicity. There are two fundamental functions. These are the sine and the cosine, which can be defined as follows. Sine function: y equals a sine open parenthesis bx plus c close parenthesis plus d. While cosine function: y equals a cosine open parenthesis bx plus c close parenthesis plus d, where a is the amplitude or the vertical stretch, b affects the period horizontal stretch, c is the horizontal shift, d is the vertical shift. Let us begin graphing the six trigonometric function. Let us go first with the sine. So let us consider y equals sine of 2x. So the first thing that we need to do is to identify its amplitude. So to locate the amplitude, it is before the sine. So is here 1. And next is to find the period using the formula p pi over the period. So p equals 2 pi over. So to locate the period, it is beside the, it is here, which is 2. So we're going to cash it out. So the meaning will be pi. So this is our period. So let's graph it out. Its period is pi. So the half of pi is 1/2 pi, and between 1/2 pi and pi is 3 pi over 4, and between 0 and 1/2 pi is over 4. So the next step is identify any shift caused by C and D. So since there is no vertical shifts, we're going to start with a 0 here. So our upper limit is +1 and the lower limit is -1. So let's plot the key points. So the first point is here. Since our phase shift is 0, so we're going to start here. Since our amplitude is positive, we are going up. So our next point is here. And our next point is back to 0. And the next point is here, -1, and back to +0 or pi. So let's connect them all. So the range of this will be -1, +1. And now let's graph the second trigonometric function, is the cosine. So the same process in graphing the sines. So let us take this example. Y equals negative 4 cos pi over 4 x plus 2. The first thing that we need to do is identify its amplitude, which is negative 4. And to get the period, we're going to solve 1/4 pi x using the formula p equals 2 pi over period. So the period here is pi over 4, 2 pi over 11 4. So we're going to multiply it by 4. So 4 times 2 is 8 pi, and we're going to crush it out, and the remaining will be pi. So we can also crush out the pi, and the remaining is 8. So let's graph it out. So 8 and half of 8 is 4, and half of 4 is 6, and half of 0 and 4 is 2. In order for us to get the upper limit, we are going to add vertical shift and the amplitude. So 2 plus 4 equals 6. In order for us to get the lower limit, we are going to subtract the vertical shift and the amplitude. So 2 minus 4 equals negative 2. So our upper limit is 6. We're going to estimate 6. And our vertical shift is positive 2 here. So 2. And the lower limit is negative 2. So negative 2. Since our amplitude is negative 4, we're going to start in a negative. So here. So the next point will be here. And the next point will be here. And back to positive 2. And back to negative 1. So let's connect them all. So it would be right there. So the range of it will be negative 2, the lowest, and 6. So let's move on to the third trigonometric function, which is the tangent. So let's consider this an example. Y equals negative 2 tan 1/4 x plus 3. So the amplitude here is negative 2. So in order for us to get the period, we are going to use this formula. 1/4 x minus pi equals pi over 2. 1/4 x equals pi plus pi equals, we're going to add pi in both sides. Pi, so 1/4 x equals pi over 2 pi. This will become 1/4 x equal pi over 2 plus 2 pi over 2. So 2 pi plus pi equals 3 pi over 2. So multiply both side by 4. So x, and 4 times 3 is 12, divided by 2 is 6. So this is the phase shift. So 6 pi our phase. In order for us to get our upper limit, we're going to add the vertical shift to the amplitude. So 3 plus 2 equals 5. So in order for us to get our lower limit, we're going to subtract 3 minus 2 equals 1. So our phase shift is, our vertical shift is 3 here, 3. On upper limit is 5. On our lower limit is 1. So this will come here, 4 pi and 2 pi, oh, so let's plot the points. So we're going to start in the center here. Here. So let's connect them. This one here. This. Now let's move on to the cosecant. It is very important to understand that cosecant is 1 divided by sine. Y equals cosec equals 1 divided by sine. So if you graph the sine function, you can graph the cosecant function. So the rules for cosecant is similar to the rules of sine function. The period of cosecant is 2 pi. So let's have 4 points. Half of 2 pi is pi. 3 pi over 4 and pi over 2. So the amplitude of sine is between 1 and -1. So write it 1, -1. So sine starts up at the center and goes up and go back down to 0 and goes down to -1 and back to 0. So instead of putting solid line, I will draw a dashed line. So let's draw the vertical asymptote. So here, vertical asymptote. In So at this point, we graph the cosecant function. Cosecant is share the same value assigned at the highest point and at the lowest point. So all we need to do is to draw the reflection. Here, this one will be and this portion will goes like this. And that's how you graph cosecant function. The domain and range, the domain of this will be x will not be equal to n equals pi. So n equals 0 plus minus 1 plus minus 2 plus minus 3, so on and so forth. While its range will be r equals to be negative infinite and negative 1. So bracket, and the union of this will be 1 positive infinite. So let us proceed graphing with the second function. So remember, secant is 1 divided by cosine. So secant equals 1 cosine. So let us begin graphing the cosine first, and then we can graph the secant. As we all know, the period of cosecant is 2 pi. So let us draw first 2 pi. And the range is negative 1 to 1. Since the amplitude of cosine is 1, since the amplitude of cosine is 1, cosine start to the top, then goes to the bottom. So this will go start here. Second point is here, and then down to negative 1, back to here, and back to negative 1. So now at this point, let us plot the vertical asymptote. Let us first connect the points. So this. So now let's graph the secant of this point. So this portion will go up here, and then we have this portion here, which just goes like this, and this portion will look like that if you stop at 2 pi. So the range is to be from negative infinite 1, and the union is 1 to positive infinite. While its domain is x will not be equal to n pi over 2, n equals plus minus 1 plus minus 3 and on and so forth. Let's move on to cotangent. For example, we wish to graph y equals 2 cotangent x. We know that positive tangent is an increase in function, so it goes like this. While the negative tangent is decrease in function, and it will look like this. Positive tangent and negative tangent. And positive cotangent is similar to negative cotangent. So this will be positive cotangent. And the negative cotangent is similar to positive tangent. So this will be negative cotangent. So let's go back to our example, which is y equals 2 cotangent x. So let's graph it. As we all, period of cotangent is pi. So the same on the left side, this will be negative pi, and the center of pi and 0 is pi over 2. So we get 3 pi over 2 and pi over 4. Same as this side. The only difference is the sign, so this will be negative pi over 2, negative 3 pi over 2, and pi over negative pi over 4. Since our amplitude is it's vertically stretched by 2 points, so imagine one here and this one, negative 2. So let us draw the vertical asymptote. So I'll go here and here. The same on the left side. So let's plot the points. Let's focus on the area between 0 and pi. We need to keep in mind that cotangent is decreased in function, so it should look like this. So at pi over 4, it should be at 2. And 3 pi over 4, it should be in negative 2. So let's connect them. It will goes like this. And this is the graph of 2 cotangent x. Let's move on in analyzing the general behavior of trigonometric functions graphs. Sine and cosine. Smooth, continuous, periodic waves oscillating between their maximum and minimum values and repeat every 2 pi. Tangent and cotangent. Defined only at certain points, they exhibit vertical asymptotes where the function is undefined. It has also a vertical asymptotes and repeat every pi. Secant and cosecant. Reciprocal functions of cosine and sine respectively producing. It has also asymptotes at the zeros of cosine and sine. And now let us proceed to its domain, range, amplitude, and period for each function. So sine function, its domain is all real numbers. Its range is between -1 and +1, while its period is 2 pi and its amplitude is 1. Cosine, its domain is all real numbers and its range is -1 and +1, while its period is 2 pi and its amplitude is 1. Tangent, its domain is all real numbers except x equals 1/2 pi plus n pi, where n is an integer. Its range is all real numbers, while its period is pi. Its amplitude is infinite. Cosecant, its domain are all real numbers except x equals n pi, where n is an integer. Its range is -infinite and -1. Union between +1 and infinite. Its period is 2 pi and its amplitude is undefined. Secant, its domain is all real numbers except x equals 1/2 pi plus n pi, where n is an integer. Its domain is -infinite and -1. Union +1 and infinite. Its period is 2 pi and its amplitude is undefined. Tangent, its domain is all real numbers except x equals n pi, where n is an integer. Its range is all real numbers, while its period is pi and its amplitude is undefined. Let's move on to the effect of changes in period and amplitude. A function's amplitude and period are crucial in determining its graphical appearance. Amplitude, increasing amplitude stretches the graph vertically, decreasing it compresses the graph. Period, a larger period shrinks the graph horizontally while a smaller period stretches. Let's take this example. Consider the function of y equals 2 sine has an amplitude of 2. The graph stretches vertically, reaching a maximum of 2, a minimum of -2. Let's take another example. So, the function of y equals 3 cosine has an amplitude of 3. The graph stretches vertically, reaching a maximum of 3 and a minimum of -3. To sum it all, we learned to properly sketch the 6 trigonometric function graphs. We analyzed their general behavior, including asymptotes and periodicity. We are able to determine the domain, range, amplitude, and period for each function. And lastly, we successfully explored how changes in amplitude and period affect appearance. And that's all. Thank you for watching.